Hello, my dear children. Hello, my dear children. This is P. Venkateshwarlu, PGT Physics. In previous video, we have already discussed about mechanical properties of solids introduction and about stress Now we need to discuss about strain and types of strain. So what is strain, my children? Yes. So whenever deforming force is applied on the body, deforming force applied on the body means the body shape or volume will changes. Understand? So consider a balloon, we can apply the force. Means deforming force. We can observe that the volume will changes, the shape and volume will changes. Understand? So based on that, we have to define the strain. So consider a balloon. We can apply the force. Like we can get after observing, we can get the volume will change. Volume will changes. Here, strain which is defined as change in configuration divided by original configuration. Understand? Strain is defined as when deforming force applied on the bodies, the body volume or shape will changes. So the change in volume divided by original volume. Or if this is lengthwise, length means change in length by original length. We can stretch a rod or a elastic rubber, the length will increases. The change in length by original length. Understand this? We can say strain. So coming to units. Here change in configuration, original configuration, it is ratio. It is ratio of same quantity. That's why no SI units. Understand? No units, mates. Understand, my children? What is strain? Strain means change in volume by original volume, or change in length by original length, or change in shape by original shape. Finally, we can conclude that strain which is defined as change in configuration by original configuration. So we have three types of strain. How many types, my children? Yes, three types of strain. First one, longitudinal strain. Longitudinal strain. Understand, my children? So longitudinal strain means consider longitudinal means it is length. Length. Understand? So consider a metal rod. So we can apply force both sides. So means the length increases. After that, the length will increases. Understand? Length increases. Here delta L, here delta L. R. So this is L means here we can get L plus delta L. L plus delta L. Here we can define the longitudinal strain means change in length divided by original length. Change in length by original length. Change in length delta L by original length L. So this we can say longitudinal strain. Longitudinal strain means change in length by original length. Change in length by original length. Understand? So this is also no units. Because length SI unit meter, meter by meter gets cancelled. Longitudinal strain which is defined as change in length by original length, my children. Okay, next volume strain. Volume strain. So second one, what is the second one? Volume strain. Volume strain. Okay, volume strain which is defined as a change in volume by original volume, my children. Understand, my children? Change in volume divided by original volume. Consider a balloon or any sphere, you can apply force, the body volume shape will changes. That is change in shape or change in volume by original volume. Okay, so volume strain means change in volume divided by original volume. Okay, understand, change in volume by original volume. So and the third one, what my children? Shear strain. Shear strain. So we know that so whenever consider this type of body, okay, you can draw this is 3D diagram. So here a force is applied tangentially, we can say we can get shear stress. So due to this we can observe that the body will deform. Okay, how like means I will say. The body will deform like this. So this dotted line indicates the change in configuration. Here the length it is dl, here L. Actually original height is L. Okay, after that the length which displays delta L. Here it is denoted delta L. Okay, understand? See here, shear strain which is defined as change in displacement by original displacement. Okay, understand? Here from this triangle we can observe, see here angle, here L, here delta L. Okay, delta L. So here in this case we can get tan theta. Tan theta is equal to opposite side by adjacent side L. Okay, this we can say shear strain medicine. Shear strain. Whenever we can apply the force tangentially, we can get shear stress. After that, the change in length by original length, it is called shear strain. Shear strain. Understand, my children? Next, very important one, that is Hooke's law. Hooke's law. Okay, coming to Hooke's law. So this Hooke's law is formulated by Robert Hooke. Robert Hooke is a scientist name. So he is formulated Hooke's law. So within elastic limit. So what is the elastic limit before that? Elastic limit. Okay, elastic limit which is defined as consider a one material which is belongs to elastic. Consider a material. So we are applying on the material force. It will elongate or compress. Okay. So after that the material or the object regains its original position and shape. Understand my children? When we can apply the force on the some material after removing deforming force, the bodies which regains its original shape and size. So in this case we are applying more than the deforming force. At that time the materials which do not regain its original shape and size. Understand? So we can apply more force means the elastic material will breaks. Okay, understand? So before that, okay, so the minimum amount of deforming force which which gives elastic limit. Okay, understand my children? Yes. So at particular limit, after getting particular limit, the elastic material deforms permanently or breaks. Okay, that limit, okay, beyond elastic limit, the material will not regain its original shape and size. Within the elastic limit means the material regains its original shape and size. Understand? So here Hooke's formulated that within elastic limit, stress is directly proportional to strain. Understand? Within elastic limit, stress is directly proportional to strain. Is called Hooke's law. Okay, so stress is equal to E into strain. E is constant, then E is equal to stress by strain. Stress by strain. So then E is called modulus of elasticity. What modulus? E is called modulus of elasticity. So Hooke's law is formulated by Robert Hooke. Okay, so within elastic limit, the stress is directly proportional to strain. So by removing this proportionality, we can keep one a proportional constant that is equal to E. Okay, understand? E, elastic modulus of elasticity, E is equal to stress by strain. Okay, so units for elastic modulus, unit stress means force per unit area by strain means change in length by original length, delta L by L. Okay, you can get force per unit area because no units are Newton per meter square, meter gets cancelled, Newton per meter square. This is Pascal. Okay, understand? So dimension formula m power 1, L power minus 1, T power minus 2. This is dimension formula. Okay, so here modulus of elasticity, stress, pressure having same dimensions. Here strain having no units. My dear children. Okay, next we have to discuss about stress strain curve. Okay, stress strain curve. Okay, see here, listen my children. Consider any material. Example, elastic rubber or iron wire. Consider elastic rubber. So we are applying force. Okay, so we are applying force means we are applying stress. We are applying what stress? Or we are applying load means the amount of weight is acting on the body. So we can observe some phenomena. First, we are applying force means the elastic rubber, it will increases length. Again we are applying force means the length increases. Okay, again we are applying means continuously the material will increase length. Okay, at particular weight, the elastic nature is will not regains. After some particular weight, particular time, the elastic rubber will breaks. Okay, understand? Will breaks. Like consider any material wire. Okay, we are applying load means first somewhat length increases. Okay, we can remove means the material regains its original position and size. Okay, we can increase continuously or gradually weight. We can observe the length increases. Again we can observe we are applying more load and we can observe means the length will gradually increases and particular weight the wire will breaks. Understand? So this phenomena we can study in the form of graph. Okay, understand that children? Then before that consider this is rigid support and this is wire. Okay, this is wire, my dear children. Okay, so and we are applying load or stress. Load means weight. Understand? So like this. First we are applying force means weight, means load increases. The wire somewhat increases. We can remove means the wire regains its original shape and size. Okay, like that gradually we can increase the weight, means gradually the length increases, and at particular time, at particular weight, after deforming force, the body, the material will not regain its original shape and size. Okay, so after that we can gradually increases, means the wire will breaks. Okay, the wire will breaks and it fall down. Okay, understand? So this phenomena we can study in the form of graph. So before that we can draw the graph between what now? We can draw the graph between stress and strain. Okay, stress, strain. This is origin. Okay, this is origin. See here, whenever we can apply the stress, okay, strain also increases. Strain also increases. Understand? So whenever we can apply the load, what happens? The length increases and means strain also increases. Understand? Yes. OA. So OA. So stress is directly proportional to strain. Stress increases, strain also increases. Understand? So then OA is equal to, OA means proportionality. Proportionality limit. Okay, so at OA, whenever stress is applying and strain is observing, okay, so in this case stress is directly proportional to strain. Understand? We can say proportionality. Both are increasing, vice versa. So strain increases means stress also increases. Stress increases means strain also increases. Okay, understand? So then again we are applying load, means we can get B. Okay, so then A to B we can say elastic limit. Elastic limit. So after getting OA means proportional limit, so we are applying some stress, we are applying some load, means we can get AB. So that is elastic limit. If after getting B point we can remove the load, means the material which regains its original shape and size. So that is called elastic limit. Understand? Whenever we can getting B point, okay, so we can remove this load, means the material which regains its original shape and size. Understand? So and we are applying more, we can increase gradually the weight or load, we can get C. Okay, understand? So then BC we call it permanent set. Okay, understand? So whenever we can apply more load than AB, we can get permanent set. So we can remove the load, means the body will not regain its original shape and size. Understand? So after getting C, we can remove that weight, means it will not regain its original shape and size. We can say whenever the elastic rubber stretch, okay, that will not regain its original shape and size. Okay, we can say plasticity. Okay, understand? So then continuously we are applying load, means what happens with less stress, strain become more. Okay, understand? So after that we can say fracture point, then CD fracture point. Understand? After getting permanent set, so we are applying some load, means some stress, means with less stress the elongation becomes more. After that here whenever the length becomes D, so the wire will breaks like this. Understand? Like this. Understand, my children? So this is the phenomena between stress and strain relation. Okay, consider one elastic material or any wire, okay, which having some elastic nature. So we are applying continuously load. Okay, understand? So we are applying some load means the length increases. Again, gradually we can increase the load means the wire becomes elongation. After that, it will breaks. So that phenomena we can consider in the form of graph. We can study that phenomena in the form of graph. The graph between stress and strain. Okay, understand? Where initially we are applying load. Okay, so load increases, stress increases means strain also increases. We are applying force and elongation also increases. Understand? After that we can apply more force or more load means it becomes A to B, means it reaches elastic limit. So elastic limit means we can remove that load, the material which regains its original shape and size. Okay, understand? So then we are applying more force means we can get permanent set. Means whenever load is applied, the point moves B to C means we can get permanent set means it is beyond the elastic limit. Elastic limit. Understand, my children? Elastic limit. After getting elastic limit, the body will not regain its original shape and size. Okay, so we are removing that load means the length becomes O to O dash. See here, permanent set means O to O dash. O to O dash. Understand? Okay, so this length, somewhat length increases. So after getting, see, we are applying less amount of stress, less amount of load. The wire, the material will increases more. Okay, more and more. Understand? So after we are gradually increasing the load, so finally the material will breaks. Understand, my children? Okay, this is the properties of the solids, so which are helpful for better material for suitable to construct building, bridges and railway tracks and everything. Okay, which is very, very important, my children. Okay, my children.